We're going to get into a little more depth and science now in the Carifree product. Chris, I'm here with Chris Moriarty of Carifree. Chris, thanks so much for being with us.
No problem. Thank you again. I appreciate it.
Okay, Chris. Well, now we've got the initial video with an overview. Now we're going to get into a little more in-depth for those who want it on the science and the technology here. Why don't you go ahead and tell us about it?
And it's one of those things sometimes I even have to hold myself back, because I'm one of those people who often makes the mistake that patients and offices are going to get excited about the things I get excited about. And for me, it's the details. You know, it's the chemistry, it's the formulations, because that's truly what makes this different.
Sure.
Carifree as a company did absolutely everything in our power to do this right. Going through academic institutions, opinion leaders, we wanted everyone to put this thing through the ringer before we treated patient one. So there's a bit of an evolution. I'm going to start with the technology. We started where a lot of other folks did, heavy focused on strep mutans and lactobacillus, being the two big name guys that were causing all the destruction. Well, that certainly suited us well for a while, but then all of a sudden the science caught up. We now know that there's about 32 different types of bacteria that in and of themselves can cause cavitation. Now it gets even more complex, because we actually know now that bacteria are very predisposed to specific locations in the mouth based on species. So really, well, and then a lot of folks didn't, and that actually led to some inconsistency in treatment. Let's take strep mutans, for example. You really only find strep mutans living on the occlusal surfaces, living in those pits and fissures. And naturally, they're certainly problematic. They do cause a lot of destruction, but that also means that if you've got a flat spot lesion anywhere, something else is causing that. So the one thing we wanted to avoid above all was inconsistency in outcome. Meaning it's the worst thing in the world. It's almost worse than doing nothing, where it works really well for this patient but not another. It works really well in this area of the mouth but not another.
And one of the amazing things is you guarantee, I mean, you know that you can get them down where you want them to get.
Absolutely.
Below this 1% level. So I mean, this really is, they do what they say they're going to do. So go ahead.
So again, all of a sudden, we knew we had a chemistry, we knew we had the approach, which we're going to talk about in terms of that bacteria, but we needed a metric, we needed something to measure. And for the longest time, we were restricted by the available technology. Well, finally, it kind of caught up. So what we're using here is actually a bioluminescent technology to figure out where the patient sits in terms of their microflora, those bacteria, good bugs or bad bugs, that sort of thing. So now that we know we've got 32 bugs we're looking for, we couldn't do what we used to do, which is actually culture bacteria, and we put it in an incubator, and it's this big long deal. We needed something that a professional could actually use. So we needed a biomarker.
I'm not going to do a lot of 72 hours of cultures and all.
Exactly. So we needed something that was going to cast a wide net and figure out exactly what the patient was dealing with. So what that biomarker turned out to be was what's called the ATP molecule. ATP simply stands for adenosine triphosphate. It's the basic energy molecule of any living cell. Well, here's how that works for us. High acid producing bacteria on average produce about 100 times more ATP than commensal healthy bugs. So basically that's what we need to check for. Because if you want to think about it in its simplest terms from a Carifree perspective, as a bacteria, I don't care what your name is. I don't care who you are. I only care if you're producing acid. And if you are, we're going to be able to find you. And
you're no good. And you were telling me that bacteria that we thought were good, now we know, just recently, they can convert into acid-producing bacteria.
This was, in terms of the science, you only get a few what I call light bulb moments in your life. And this was actually coming from a couple of researchers out of Japan, Takahashi and Naived, about 2008. So it's very, very recent.
Very current.
Well, what we found is that bacterial behavior is going to be ultimately driven by the environment in your mouth, specifically the pH of your environment. Where if you took what we mentioned, a bacteria called Strep gordonii, this used to be the gold standard in terms of healthy bugs. Well, what we were able to discover and realize is that in the wrong environment, in a low pH environment, Strep gordonii will actually shift and evolve in under 20 minutes and become a high acid producer, producing just as much acid as any of the guys we knew about, but you never heard anybody talking about that because we didn't know. The science just hadn't caught up.
So this device will tell us which one that they're producing the
absolutely. So we'll be able to pick out, no matter who they are, we'll be able to find them with this.
So what are we going to do then?
So once we realize that the patient's not where we want him to be, they become a candidate for the treatment. So as we mentioned earlier,
you can see it very clearly on that device that they need help.
Absolutely. Check mark that they're good or an X that they're bad. If they get that X, we just tell the patient something very simple. We just say, you know what? We're going to go ahead and shift that microflora. We're going to get out the bad bugs and we're going to get in the good bugs. because reforming that biofilm is really the name of the game. There's research out there that shows that a biofilm can remain stable for a period of years. I mean, you get once to self-sustain. It's actually a very durable, very perfect structure. It's going to take something for it to deconvert. Those
like
things.
The weeds in the yard. Once you get all the weeds out, it's tough for the weeds to get back in.
Absolutely.
There. Same thing here.
And we use that analogy a lot.
Oh, you do? Okay.
So, which of course you knew.
There we go.
So when we walk through the system, resetting the biofilm is the name of the game.
Okay.
Month number 1, again, we're using a very low dose of sodium hypochlorite to dissolve all the biofilm and kill all the available bacteria. Okay. Kill time studies behind this are about 0.34 seconds.
Wow.
Now, one of the things, and if anyone's ever curious, I'm happy to show you why we went down the road of sodium hypochlorite, why we didn't go with chlorhexidine, chlorine dioxide, iodine, alcohol, and the rationale is very simple. Nothing was more effective and nothing was more broad spectrum.
That's good enough for me for this video.
Absolutely,
okay.
And sometimes even a patient will ask, they'll say, well, why do you use sodium hypochlorite? And I say, well, because we look at the studies and nothing's better.
Right.
And you make the decision as a professional that you'll never give the patient the thing that was second best.
There you go, okay.
Simple. So, once we've wiped them out, once we've cleaned everything out, this what basically boils down to a pH therapy, a xylitol therapy, and a little bit of remineralization.
Xylitol, okay.
Exactly. And xylitol, of course, is one of the newer things in the dental arsenal.
How long have you, I'm hearing more and more about xylitol. When did this come about that this was a wonderful thing?
It's actually, it's an interesting evolution. Xylitol was discovered decades ago when actually being used as a sugar substitute during wars. They would extract it from birch trees. The only problem was that the refinement was fairly cumbersome, and so it made it very, very expensive. As the years have gone on, they found more efficient ways to get it out of things like corn and get it out of other avenues, because it's just the xylose portion of a plant, but once we get it out, it's a very powerful dental tool.
So how long has this really been prominent now in dentistry?
I would only say within the last 3 or 4 years where it's really been that available, where you see it popping up in gums.
Okay, sorry for that little sidelight there, but okay, let's
Well, no, because xylitol is a big, big portion, because it's a double-edged sword. Because xylitol works really, really well, but you need quite a lot of it, between 6 and 11 grams every single day for it to be truly therapeutic.
It's not the percentage or anything like that. You need the
grams. You need to know how many grams.
People are talking percentages of xylitol or things like that. That's not the big deal. It's the number of grams that you're getting per day.
Absolutely. So one of the things that we did first and foremost is we fortified the rinses to the point where they're getting 3 grams per swish.
Okay.
So using it twice a day, they're already hitting at least the low end of that. So they do chew some gum and do the other things. We're going to be really healthy and we're going to be right within that range, which is wonderful.
8 to 10 grams is what they need. Okay.
Exactly. So the xylitol is certainly going to do its part in helping control the bacteria.
Right.
But remember what we just mentioned with Strep gordonii, the shifts, the conversions, those good bugs going bad. Any one of those bacteria can undergo about 84 genetic mutations, we found out.
Wow.
So preventing that is the big part. That's often what makes the difference between you and me. Where we could even be in the same household, we could be in the same dietary habits, but ultimately at the end of the day, we're different. Our body chemistry is going to drive this bacteria a little bit differently. So we need to do something to control that.
Okay.
So a heavy part of what we do is a pH therapy. Because when we looked at all the overarching things that could ultimately drive whether or not those good bugs were going to go bad, it was pH, pH, pH.
Okay, and we're going to do a short little video after this one on that that's very interesting. But let's go ahead here.
Yeah, absolutely. So again, we're trying not to just kill bacteria. We need to reform that biofilm because we need those matrices to come back.
Right.
Because when these things develop, they're multi-levels, they're multi-tiers, but we need that durability. And of course, once we've established that, then it goes back to the piece of technology. So that's how we're going to track the patients long term.
Right, then you go back to the technology at 3-month interval to test them again, make sure that they're where you want them. If not, you get them back on this for another month. I think you had one patient that actually needed 3 months treatment.
That's true.
But out of many, many, many patients.
Because when you think about the infection itself that's causing this decay, I almost equate it to like a fire. And some patients, they just have a bigger fire, and if this is your bucket of water, sometimes it's going to take 2 buckets.
Makes sense.
Yeah, and one time it has taken 3, but again, it's very, very effective, and we will achieve our goal, and we always have.
Okay, great. What else would you like to tell us then to wrap this up here?
Well, it's one of those things where we really rely heavily on the training program that we put together with it.
Right.
Only about 30% of that's on the science, because while it's important for us to know that in a professional sense, that's not what you're going to talk to the patients about.
Right.
So really what we've done is condense it into a 3 to 5 minutes, start to finish, risk assessment, treatment, and of course that patient understanding is paramount.
And on the back of this kit, by the way, that the patient gets, it's right there what they're supposed to do month 1, month 2, month 3. It's just very simple right there.
Absolutely.
Anything else, Chris?
No, I think that's it in a nutshell.
All right, Chris, thank you so much.
I'll thank you again. Appreciate it.
Great.